Gem 1. Uh, we will be going. Just got notified that we have a meeting right now. But okay, that's by 3. There's another live stream I'm supposed to be part of right now. I think it just clashed. Calendars clashed right now. But let's see. Let's see. What can we do? Um, yeah, let's just get started. Let's get started. Then see how far we can cover. Maybe we can make it a two-part series. Yeah, GM guys, let me know some background music. Spotify. Yeah. I know music. 1 minute. Take this one. This. Okay, so we're good to go now. So welcome. If you're just joining in the chat, just know where you're joining in from. It's likely going to be Twitter. I don't think there's so much people watching us from YouTube. Most everyone is on Twitter these days. So yeah, just see. Try to pick things up from where we left them yesterday. Yesterday we talked about uh 1 minute. Talked about AccountsDB also. So this is like a third, like this is the fourth one actually in the series, but this is like the third one into AccountsDB and stuff. So let's do. I'm trying to get some people into the room. 1 minute. Yeah, let me pull this up. The anchor founder accounts DB part 3. Let me see what the audio looks like. 1 minute. Uh, are we good? Are we good? Let me see. So we're good. Just pull that down a little bit. All right, so let's get started. GM. Yeah, we did a little bit of we did a harness. Just was a harness, a benchmark. We did a benchmark to see what accounts would look like. What the accounts cache, the read and write cache. What's it look like when you make transactions to when you get an account, when you get the details of an account. So before the accounts gets copied to the read cache, how long it took previously. So let me just share. I'm share my screen about that one on the okay. This one. Let me share my screen to show that. Yeah. Next, we have open globe. No, this one. Okay, we already have this. The was accounts test. Then let's put yeah, yeah. So I said I was going to run this in okay, previously. Let me start from basics. Previously, we were getting inconsistent numbers, like numbers that are not what we would expect to see, and that was because we were connected to DevNet, and I was trying to benchmark on DevNet, and the problem with that is uh, when you send a transaction over the internet or the network, you there are a lot of things that might cause delays or lags, especially when you're using a home internet. So that's why we're getting numbers that did not add up because it feels like it's regressing instead of. Let me show you what that looks like. So we did a benchmark for the V1. So the V1, we close this. So the V1, we had the first read for an account took 959 milliseconds over DevNet RPC, and that was not what we're looking for, yeah. But it was pretty late. Then every other one was 200 to 30, 200 to 30. Then we got to the second account that was read. At least we should also be expecting to see another 900 and something milliseconds, yeah. But no, we got we got 200 and something milliseconds for another this next account that have not been loaded into the cache yet. So it's a fresh account. It's an account that was created previously a long time ago. It was not existing. Hopefully, it was not existing in the read cache, but it's still giving us 121 milliseconds. And it was just the data we got was not what we were expecting to get. So I figured out might be a problem with the network we're connected to. So we're on DevNet, and there's no way to prove that your internet connection is reliable enough to give you consistent results because there'll be jitters and all and all and all. So I just said, okay, let's do one more time. For this this 900 outlier was because the I think the connection path to RPC was cold, so it was not warm yet. So immediately you did the first connection to RPC, then you already established the connection to the RPC and sending transaction were cheaper, yeah, for time. But so we said to be clever about it and try to actually benchmark this with a network that's running on our PC. So we can get the actual timing of it. So I think this one is for second time I tried DevNet. Then we're getting 300, but it was still consistent. We don't want to get consistent. Well, at least this one was 307.09 and the next one was 307.21. It's wide. The gap is not so wide. It's not so wide that acts what we would want to expect. So let's just and again this is milliseconds. So all of the if it's a nanosecond, you'll be able to see how big the number is. But all of the it's still not adding up. Is essentially what I'm trying to say. It's not adding up. It's still tight. It doesn't look like there's any difference, and the numbers are not consistent. So again, RPC issue over DevNet with your internet, your home internet. So I said, okay, let's do. I tried to do it with test. I think this one is testnet. Testnet. Yeah, local net rather. So this was local net. I tried running this on local net, and now we have interesting things to look at. So on local net, the first account, I did just one transaction to have a handshake with the network first. So but it did not affect any of the accounts. Then we have the the first read of this account. That's it took 0.5 milliseconds to read it first. To read, so the first time we read the account from local net, it took 0.5 milliseconds. Local net running on my laptop to fetch the account. Then the subsequent one, because hopefully we wanted to prove that the subsequent transactions would mean this account already exists in the read cache, and subsequent reads would already mean the account is already in the read cache, and it will be easier it will get a lot faster because it's already in the cache as opposed to being in the account files. So that's what we proved over here, and you can see how interesting the numbers start to reduce. Yeah. So for the other account also, the this one is and after the transaction, okay. Now we try to see if you've read an account, then you write to the account. Now that account will be in the right cache, no longer in the read cache because you created it before it's now flushed to the account files. So it will be in the right cache. Now, if you try to read an account that's in the right cache, how long does it take? So we saw this one was 0.402 and was consistent, and now it even took lesser time because it is already, or I say, it's already in it's now in the read cache again. But yeah, let me see. 0.5, we had 0.3 consistently after the first read. Then after we wrote to it, we have in zero point 0.4. So yeah, it was in the right cache. Maybe the right cache takes more time to read from the right cache than being in the read cache. So if you've read it in the read cache, if you've read it and it's now in the read cache, it's now easier to fetch the account essentially. Well, we'll get to all of that in a minute. Then for the second account also, the first transaction took 0.36 milliseconds. Then the subsequent read took 0.32, 0.33, 0.3. It's not the gap is not too wide. What am I saying wide? It's not too wide, and but yeah. Then pre post also we had some numbers. But let's look at the third account. Yeah, third account also showed this account. First time we read this account, it took 0.63995 milliseconds. Yeah, rather, milliseconds to fetch this account. Then subsequent accounts were 0.4, 0.3, 0.3, 0.3, and all, and all, and all. Then after we wrote to it, so we're just trying to demonstrate and demonstrate how the relationship between reading an account from when the account is in account files versus when it's in the read cache versus when it's in the write cache. So that's basically what we're trying to do. So read an account first in account file. Then once that is read, it's now a recently read account. So it will be in the read cache because you might want to read it again very soon. So the system puts that in the read cache. And reading from the read cache is now faster than reading from account files. That's one thing we wanted to prove. I wanted to prove that if you write to an account, it's now stored in the right cache because you just mutated the account. And we want to test that. We want to see how fast it should be to read an account that's in the right cache. And once you've read it, you should also move to the read cache now, right? Hopefully. So we want to see what's actually happening. This one just gives us numbers, but overall, what we want to do, essentially, what we want to do at the end of it all is to be to monitor. That's the end goal. The end goal will be to monitor this account and see uh how the accounts how the account DB is acting to the accounts in relation to the account here. So yeah, so let me show you the I think my camera went off. Uh, I will try to fix that. But yeah, while I'm doing that, let me show you the yes the benchmark on localnet. Okay, so I would want to read that as an MD file. Yeah. So yeah, we did one transport warm up to the RPC. Then to make sure none of our first account reads is going to be held to be the warm up for the RPC. Yeah, so just that one to warm up the RPC. Then we now do 45 read, one write, then 45 read again. So that's what we did for all five accounts. Yeah. So first read for this account was 0.552 milliseconds. Then the median of the remaining 45 read 44 reads were 0.32. So that means it was relatively quicker to read an account after it's already in the read cache. Then for the second one also, this one is kind of high for the median values. Yeah. The third one 0.64. Then after reading it first time, it was subsequently quicker to read it again in the remaining 44 reads. So it shows it's kind of proved what we're aiming for here. So all of these four ones showed what we're aiming for. All of these four ones showed what we're aiming for, except this something must have happened along the line here. Like again, we cannot see what's happening inside the accounts DB unless we monitor so eBPF or something. And that's essentially the aim of this live stream, yeah. To be able to monitor accounts DB, just like we did proof of history previously. I did proof of history. I don't want to run that right now, but if you want to say that, maybe I can attach a link in the chat or something. So yeah, post read after we have read it for 45, read it 45 times, then we write to it. We send 0.1 so to the account. It's now when the write cache. Then we try to read. Once we read the account, we calculate how long it took also. So this one was for that account was 0.403 milliseconds, and subsequent read after that was median around 0.35 milliseconds. So that's basically what we did for this other part. That's essentially what this is explaining. And I attached that in the link. Let me see. I attached the link to that in the GitHub. I attached the GitHub link to. Let me put this in the chat here also. In the previous post, every day when we do this live stream recently, I try to show a recap. So in the recap, I added the link. I posted it in the chat now. Let me see if I can bring it up on the Jumbotron or whatever it's called. Uh, yeah, this one. Yeah, so this was the link. This is the GitHub where it's at account exploration Solana. I can check the entire repo for. Let me even try to share that real quick. So essentially, this is what I posted. Then if you come out to the account exploration Solana repo, you see how this is the benchmark. Okay, this is the JSON. This JSON file for all the runs. So if you want to check it and validate it yourself, that JSON file for the runs. Then this was the MD file, and this is the code, the AI code, the codex code. Yeah, so that's basically it. All right, so let's get into try to start what we want to do today. We can cross this back and let's see. All right, we were able to get to purging yesterday. And what we want to do now is implementation details. Yeah, I'm talking about bank forks also yesterday. I said it was a whole lot of a whole lot. So let's do implementation details. I would have to be off on another call by the next 10 minutes. So I should resume after that call, maybe later in the evening. But for now, the next 10 minutes I have to be out. I have to be with the tribe, the Turbine tribe. Turbine is having an orientation for their what's it called? Their students this cohort. So yeah, implementation details for AccountsDB says loading from snapshots. So this will give us more granular experience over what has been explained on the high level. We will begin with a more detailed outline describing how a validator loads account from a snapshot. First, unpacking a snapshot. So, like they said, you download a snapshot from a pair in the network, which may include a full snapshot and an incremental snapshot. So, what's a full snapshot? What's an incremental snapshot? We're going to get into it in a minute. The full snapshot includes, let me bump it up one step. Yeah, okay. A full snapshot includes all the accounts on the network at some specific slot. All of the accounts on the network at that specific slot. So if it's accounts that uh all the accounts is essentially on the network, all of the accounts on the network at a particular slot. So you get the recent state of the account for that slot. Then incremental snapshots are smaller snapshots and only contains the account which changed from a full snapshot. Yeah, they'll show an example. For example, if a network is on slot 100, the full snapshot should contain all accounts at slot 75. If the full snapshot could not should could contain all accounts at slot 75, and the matching incremental snapshot could contain all accounts that changed between slot 75 and slot 100. Yeah. Okay. So it's saying full snapshots can be expensive to create often because they contain all accounts on the network. Yeah. Whereas incremental snapshots are relatively cheap to create since they only contain a subset of the network's accounts. In light of this reality, the typical approach for validators is to create full snapshots every once in a while and create or update incremental snapshots more frequently. So validators are going to be creating snapshots every once in a while, full snapshot every once in a while, but always have increment have incremental snapshot more frequently. So this is an example of what a full snapshot versus an incremental snapshot looks like. Full snapshots are there to the following naming convention. We have snapshot, full slot, hash, and star.zsc. Let me try to bring that up one more time. We're done with this. I can close this. Not T. We have a terminal here. We have a terminal here. Let me bring this up here. I think that was in CD code test ledger. Test ledger. Let's code test ledger. So don't worry about this one. So yeah, I had to, what's it called? My validator was not advancing slots yesterday. When I was try to run the stuff, the benchmark. So I had to reset my validator, my local net validator. So if I do Solana testnet test validator, now let's see if it advances slot. You see, some files changed over here. We'll try to do that. It's initializing because a ledger already exists, but some files changed over here. But we'll try to do that again. Is it? Yeah, it's advancing slots now, thankfully. Yesterday was not advancing slot, it was stuck somewhere. So I had to reset the validator. And yeah, so let's close this, stop this for now, and see what the article said. So this is a snapshot for slots 21500. So snapshot slot 21500. Yeah, slot 21500 at the transaction hash 7LP3S. Yeah, block hash rather, or whatever hash. So full snapshot, then a hash .zst. That's the full snapshot at this particular slot. That's the full snapshot. So this would if there's a new network on my local net, they could download this and unzip this to get the full snapshot at 21,500. Then 21,600 also has a full snapshot at 21,600. But I don't think we have incremental snapshot here. Yeah, do we have incremental snapshot here on local nets for this local validator? And if you check accounts like we shared already, there is snapshots accounts that were 21,500.231, maybe fork 231, however. Open anyway, open with Exeditor, and you see all the accounts that interacted with with the validator at that slot. This were the accounts that are used for the runs. A lot of padding, a lot of padding, a lot of padding, a lot of padding. Yeah, essentially all the accounts that were modified in this slot. And the next one, so that just shows exactly what was said here. But we don't have incremental snapshots for this local net, so we cannot check that one right now. But it will look like this incremental snapshots 1025 would mean incremental snapshot from full slots to incremental slots. An incremental snapshot follow the following naming convention. For example, incremental snapshot 10 to 25 and the hash would mean an incremental snapshot which builds a full snapshot from slot 10, that was the last full slot, and contains only all the account changes up until slot 25. So it contains all the account changes up until slot 25. So it's giving you basically account files, only the accounts that were changed, not all the accounts on the network. Because we already know all the accounts, the state of all the accounts on the network from the full slots. But now, how about the changes that happened from slot 10 up to this moment? So that will be lighter, that will be cheaper to it will not be as heavy as the full slot. Yeah. So that's basically what it will be faster to be lighter to download this one since it's not the whole state, it's not the state of all the accounts on the blockchain. Now that's lot, it's just all the accounts that changed on the network. So that's what the incremental slot is. Up until slot 25, and it has an hash of that. A matching snapshot and the incremental snapshot will have the same full slot value. A matching snapshot and an incremental snapshot will have the same value. What does that mean? Have the same value full slot. Uh, when the validator is starting up, since the validator can have multiple snapshots downloaded at once, it will find the latest snapshot and the matching incremental snapshot to load and start up from. So it will load and start up from the uh, the incremental snapshot. So it looks for the latest snapshot, then the matching incremental snapshot. It will load from the matching incremental snapshot. Download the snapshot. The validator starts participating in gossip to join the network and identify other nodes. Gossip. Say it. There's a gossip here. There are different parts of Agave. See the document. Agave ls. Should see, yeah, gossip CLI. Yep. So gossip is how validators communicate with each other. So they communicate with each other over gossip. Participating in gossip to join the network and identify other nodes. I have to go and I just checked the time. It's 3 p.m. my time already. After a while, we look for nodes who, let me check, do I still have extra time? I don't think I have extra time anymore. Guys, just we'll have to jump off here, but it's actually getting interesting already. And I will do a second part while I'm back from Turbine. Just I forgot that I had Turbine in my calendar. Uh Sorry guys. So meet later and we'll continue from all of this. Don't forget the aim is to be able to load. Firstly, the aim for this live stream is to see how to load an account from account files using the using the way Agave repo does it. So we're trying to test it to see how it works because we already have a working local nest validator here. We have account files here. So we can try to load the account inside these account files, any of the accounts inside the account files, and try to read the accounts that are inside of it. I will be able to validate because all the accounts we tested with for that slot were only the accounts that, let me see, the dot ls, no, let's cd account test, cd accounts db benchmark, then ls everything that has a .json. uh Cannot access the JSON, no such file directory. Accounts DB benchmark in list of the notes. Oh, not yet, sorry. Now it should work. Yeah, so only these five accounts, or maybe some other ones, were the accounts that interacted with the accounts DB. So with the local test validator. So we should be able to verify that all of these accounts are in these account files. And that will be a good win for the first step before we start exploring other parts of the of accounts DB. Yeah. So yeah, I'm signing off for now. I'll jump back in this evening this evening to finish it up. Thanks for your time, guys. GM.